Okay, now we're going to look at quadratic equations, and we're going to look at a vertex form and a standard form. First off, we have the vertex form, and we're going to look at this as basically a transformation, the same kind of thing we looked at the end of last chapter. But notice one real important thing here is I changed that from a positive to a negative, or a subtraction. And that should help us when we look at transformations, because if you recall, when that was a plus, we added to the input, it kind of made things shift the opposite way that you would think. So by changing that to a subtraction, it should help us out here. And let's look at that on a graph and see if you agree. Okay, so here we go. So we're going to look at our parabola now. Notice the equation is y equals, or f of x equals a times x minus h. And once again, I point out that there's a subtraction sign there. Right? So now when we look at this, what happens? I think you should show very quickly that the a, if a gets larger, it's a vertical stretch, just so like we learned last. I don't have it set, but I think if I put in a 1/2, it would be a vertical shrink. But then if a is negative, then it just flips the parabola over. Okay, so we're good on a, hopefully. A equals 0 is not a good number. A equals 1. Right? So what does the h do? Notice once again that I changed from an addition, adding to the input, to subtracting from the input. So now if I put in 3 for h, it's actually moving the graph to the right, the same number of units that h is. If I make a h negative, it moves the graph to the left. Okay, so far so good. So let's make h 0 again. Okay, hopefully you can convince yourself that if I add positive to the function, to the output, moves the graph up, negative moves the graph down. But more importantly, let's look at this point. And let's just label that point. Obviously 0, 0 now, but what happens? H is 3. Look at the x-coordinate of the vertex, right? Now as I'm changing k, once again, look at the y-coordinate of the vertex. And now if I change both of them, I think you can convince yourself why this is called the vertex form. All right, going back to this vertex form, now what do we know? All right, we know that when all right away, if, A causes a vertical shrink or stretch. And more importantly, if A is greater than 0, then we have a parabola that points up, opens up. And if A is less than 0, we have a parabola that opens down. All right. H obviously shifts left and right. And K shifts or slides up and down. But more importantly, since we call this the vertex form, H and K are now the coordinates of the vertex. All right. So now let's look at this standard form. How does that compare? So that's vertex form, here's standard form. And what does the standard form give us? If we put the equation, and we can manipulate any equation to make it look like this. All right, I hope very quickly you can see that if A is greater than 0, the graph is going to go up. A is less than 0, the parabola opens down. Well, how about f of 0, right? So f of 0, if we put in a 0 for x, you'll find that f of 0 equals c, or the point 0, c is on my graph, and it's too bad I didn't choose my graph a little more wisely. But if we follow that parabola up, we will see that it'll cross the y-axis at c. So we know some things right away from looking at the equation. All right, I'm going to erase that stuff. The next thing we know, all right, The next thing we know is recall that these 2 points here, the x-intercepts, or the zeros, right? We could calculate them using this formula. You know, x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Well, let's analyze this. This is actually, I'm going to break this into parts. It's the opposite of b over 2a plus b squared minus 4ac all over 2a. And it's the same thing, opposite of b minus 2a minus the square root of b squared minus 4ac all over 2a. Okay, so let's think about this. So let's look at this point right here. That's the 0. It looks to me like we go some distance, negative b over 2a, and in my example, either b or a had to be negative. So it looks to me like you measure over so far, right? And that distance is negative b over 2a, or the opposite of b over 2a. But we got to go a little bit further, right? So that distance right there must be that, you know, if I calculate that, whatever the square root of b squared minus 4c over 2a is. Okay, you got it? So far, so good. Now let's look at this other point. We'll do that in black. All right, so this other point, we go over the same distance. So we go the same distance, but now we subtract actually the same amount, but we go backwards, all right, in order to find that point, all right? So we added, all right, we went over some distance, negative b over 2a, and then we subtracted that length, right, to find the other 0, if you will. So I hope what you'll see is that point right there, or that distance, negative b over 2a, is the x-coordinate of the vertex, which above was h. So there's a little check on your math. Negative b over 2a and h should be the same number. And again, we call that negative b over 2a since it's actually a line, x equals negative b over 2a. We call that the axis of symmetry. And negative b over 2a is the x-coordinate of the vertex. So once again, from standard form, we can look at the value of a tells us, does the graph open up? Does the graph open down? Is there a stretch? Is there a shrink? C is the y-intercept. And if we do this calculation, negative b over 2a, negative b over 2a is the line of symmetry, or the x value of my vertex.